ये कह रहा है आप फनी लग रहे हो चश्मा लगा के।
Guys, good evening to all of you. Are you able to hear me?
Yeah, loud and clear.
Yes.
Good evening.
Yes, you are audible.
Okay. So I think this is maybe the strength. Is anybody else going to join?
Ravi, I believe we were 32 to 34 members. Maybe we can make
Okay.
1 or 2 minutes.
Okay, this is the first day or which day it was?
Day 3.
Day 3.
Second day.
Third
Third
day.
day.
Third day. Okay. Okay, you are able to see the slides, right? Yeah.
Yes, it's visible.
Okay, guys, we will continue. Okay. So yes, welcome you back to this root cause analysis. Okay, which focuses on identifying the root cause of for the specific problem. Okay, so this is the first time I'm meeting you guys. I'm Dr. Ravi Kumar. Okay, we are a part of the Vision Excellence. I have a doctorate, okay, with 2 master degrees in design as well as in project management. And the main thing which connects is I am a master Lean Six Sigma, master black belt. With 24 years of experience, worked in industries as well as universities. Okay, a lot of technical publications, so many projects, patents everywhere. Okay, now let us move to the content. So what is the ultimate aim of doing this RCA? Okay, what is the ultimate aim, guys? What is your consideration? What is your need for doing this RCA? See, all of us are able to identify the root cause in one way or another. Okay, so this RCA aims, it is a systematic method, okay, used to identify the true underlying cause. Actually, a lot of times people used to identify the cause, but whether it is a true underlying cause of problems, okay, is important, because most of the times, rather than addressing the problems, we go ahead and address the symptoms. Do you agree with me, guys? Yes or no?
Yes.
Yeah. So we should be able to identify the difference between the symptoms and the cause. For example, if person is having severe sneezing or cough, then he might be having a cold. The cough, the body pain, and the other things may be a symptoms. If you treat the symptoms, and obviously the root cause is not going to be eliminated from your system or process or equipment. So RCA, root cause analysis, helps you to identify the true underlying cause of the problems in a systematic way. Okay, instead of identifying and addressing the addressing the symptoms, which most of the times people are continually doing in industries. Okay, see, in industries, many many problems are repeatedly solved temporarily. Do you agree with me, guys? Without,
Yes.
without understanding why they occur. They simply resolve the issues on day-to-day basis, and they keep on moving and operating the process. But they don't go for an analysis why they occur. But this RCA helps you to eliminate this kind of cycle, which is occurring in many industries. It is frequently happening in many industries. They try to control the problem, they try to cover up the problem, and they will go on with the operations. But here we are trying to eliminate this, reduce this cycle by focusing on permanent solution, by identifying the true underlying cause, by identifying the root cause. Okay, so obviously it is used in continuous improvement in quality management systems like Six Sigma and lean manufacturing. So instead of reacting to the defects, the organization needs to proactively identify causes and prevent the recurrence of this kind of problems. So organization, if they want to proactively, okay, implement certain solutions, certain tools, okay, to eliminate the defect, then they have to go with this RCA. See, for example, let us say in a machining industry, let us take a machining industry. So how many of you are from production, quality, software, banking? I don't have complete details.
Quality.
Yeah.
Production.
Quality.
Quality.
Process.
Okay.
Design.
Engineering.
Okay.
From quality, sir.
Okay.
From quality.
Anybody from software, banking like that?
No.
Okay.
Yeah, myself.
So Shankar, okay. You are from software industry.
No, I'm from the operations financial services industry.
Okay, okay, great. Okay, so if you take a machining industry, the tool is one of the important component in many machines. Okay, suppose the tool is continuously breaking. Okay, they simply solve temporarily by replacing the tool. But RCA try to reveal real issue, the root cause, okay, behind that tool breakage. The tool is breaking continuously, replacing it with a new tool is not going. The tool is breaking continuously, okay, in an intermittent manner before the life, then obviously there is some other cause, some other root cause lying. So we need to find out what is that root cause. Either it may be the incorrect feed rate or it may be the operator skill. That gap may create this kind of problem. So RCA helps you to find out this kind of things. Okay. So and apart from that, RCA, it uses a lot of tools and techniques, not just one or two, a set of tools that will help you to, okay, identify, validate, and eliminate the root cause. So first you need to identify the root causes, then validate them. What is validation? See, we may be claiming that this cause may be the root cause. So we need to support that with proper evidence and data. So that is validation. So RCA will help you to, the tools which we are using in RCA, root cause analysis, will help you to identify, validate, and eliminate the root cause. So the problem is not resolved temporarily. The cycle has been broken and the problem will be solved permanently. And no such problems will occur in the future if you are following the SOPs correctly. Okay. So here the goal is not only to eliminate the problem, but also process improvement. And the efficiency of the process also increases, enhances. So all the way, RCA objective is not only resolve the problem, but also it looks that the process improves because the problems which we have been dealing for a chronic time, for a long time, has been eliminated. That obviously will improve the efficiency of the process. So it is a dual target. Okay, goal has been achieved. So in many areas, we have been using this RC. As you people are aware of, you are having quite a lot of experience in industries, right? So you are expertise and you have sufficient knowledge in your industry. So you can see this is used in manufacturing, it is used in software field, it is used in healthcare, it is used in service industries also. See, for example, a software industry, okay, in a software industry, the server is frequently crashing down. Earlier, it may look like a simple issue, but RCA only will help you to reveal the poor coding which may be running on the background of that particular thing. So This kind of long-term chronic issues which affects our process, which reduces our improvement, which affects our efficiency of the process can also be identified. Okay, so that is what we are trying to emphasize in this RCA. Okay, so all of you now have a clear picture about what this RCA is going to do. Okay, so we are not going to treat symptoms, guys. We are going to treat the causes. We are going to find a solution for the causes. Okay, so if you have any queries, you can ask me at any time. Okay, so the first and initial stage in the RCA journey, okay, is a simple problem tools, which may include tools like 5 Ys or YY analysis. Okay, so this YY analysis, you can see, it will help you to resolve the problem in a straightforward manner, which requires quick solutions. See, if you are able to identify a problem, that if you are able to identify the root cause of a problem using a 5Y analysis or YY analysis, most of the times it may be a simple problem. Okay, so we'll be able to identify the solutions easily. So normally we used to call it as straightforward problems with simple solutions. See, for example, if a machine stops, for example, if a system is not working, okay, then you simply ask why, and you repeatedly you can keep on asking the question until you arrive at the root cause. So this can help you to identify the cause easily. And if it is a simple problem, and you'll be able to recommend a corrective actions also. So this is the first stage in the RCA. So in the first stage, you may be dealing with simple problems, and you'll be using simple tools like YY analysis. So you'll be seeing YY analysis in the later slides, so no need to worry about it. The second stage is a structural analysis method. See, all of you know about fishbone diagram, right? Fishbone diagram, Pareto analysis. These are used when the problems are quite complex and involve multiple causes. When you have multiple causes, you cannot go, you should not use 5-way analysis, guys. You have to be quite careful. Sometimes this is what normally people do. When they
Sorry,
know,
excuse
yeah,
me. Yesterday we just covered the Pareto, so fishbone and other things. If you can give a idea, glimpse idea of that, so
yes,
many
today we
people
are
will.
not going to cover Pareto. Today we are going to see fishbone only. No
Pareto
need to.
yesterday we covered. Other than that, we had not had a look into the other techniques. That's what I'm
So you
mentioning
have
it.
covered fishbone analysis also.
No,
Yeah. So we are not going to deal with Pareto today.
Pareto
We are
yesterday completed, sir. That's what I'm saying.
we are not, please listen, we are not going to see Pareto today. We are going to see fishbone analysis only. Okay?
That's what I'm mentioning, sir. Okay, thank you.
Okay, thank you. So Pareto is not what we are going not we are not going to deal with Pareto today. Okay, since Pareto was covered yesterday, let us forget Pareto today. We will see fishbone analysis. So we will see YY analysis, then we will see the fishbone diagram. So the fishbone diagram, it helps you to find out, okay, when you have multiple causes. See, sometimes there is a possibility that a particular problem may be the result of, maybe the particular problem may be as a result of multiple causes. Y-way analysis will not help you to identify that, but fishbone diagram or Ishikawa diagram or cause and effect diagram will help you to do that. For example, let us take a defect in automobile assembly, which may arise because of machinery or because of material or manpower or because of some kind of consumables or because of methodology. So we are not sure which one. So if you use 5-way analysis for this kind of multiple causes problems, then obviously it will not be effective. So when the problem is as a result of multiple causes which you are not sure about it, then you have to go for this kind of tools like wishbone diagram. Okay. Then the third stage is a process-based approach, okay, which involves observing the actual workflow. Okay. See, sometimes there may be some issues which will be connected with the flow of the process. Okay, so in this case, you need to first study the process, observe the process, collect data from the process. So in this, we'll be using tools like process mapping, which will help identify the inefficiencies. For example, let us take in a paint industry. Delay may occur due to poor workflow rather than machine failure. See, if there is a set of process happening, if anywhere, if there is a bottleneck, okay, then obviously that may lead to inefficiency. So process mapping will help you to identify that. Then finally, the fourth stage is a validation tools, including statistical tools, okay, like scatter plots, control charts. So these are used when decision requires data validation. See, for example, you may be having a suspicion over that particular cause, and you may be very sure, 80% sure that this cause is responsible for the defect, or this cause is responsible for the poor workflow, or this cause is responsible for the inefficiencies, poor raw material usage, or poor outcome. But you need to confirm that with the help of data. That is called validation. So scatter plots and control charts will help you to confirm the particular claim which you are making regarding the root cause. Okay, that is what we used to call it as validation tools, advanced validation tools. Okay, so generally, overall, no tool can be used to resolve fix for all problems. So the choice of the tools always depends upon the complexity of the problem. Okay, and the availability of the data. What do you mean by complexity of the problem? See, the problem is not, you are not aware of the source of the problem, the cause of the problem. Okay, and if you doubt, if you have a suspicion that it may be because of many more causes which you are not clearly aware of, which you don't have sufficient in-depth knowledge about it, then obviously it can be termed as a complex problem. Okay, so whenever you have insufficient data, whenever you have insufficient awareness, idea, knowledge about that particular problem, if you are able to resolve it, and if you are unable to identify the correct cause using simple tools, then the problem became complex. Okay, and if you don't have previous records about the similar problem, then it may become more complex. Okay, then also based on the availability of data, also you have to choose the tools. Okay, so we will see it based on the data which you have in your hands, existing and previous, you have to choose the tools. And also the important thing is based on the risk level. See, for example, if you use a simple tool and if you are going to implement the solution by identifying the cause using the simple tool, and if it is a critical process, if it is an important process, see, for example, let us take, let us think, uh, let's say a person is going for a medical checkup. A doctor doubts he may have a first level of the cancer. So what the doctor will do, whether he will decide based on some simple test, or he will go for some multiple uh, high-end confirmation test. What he will do, guys?
Multiple tests.
Yes, before risking that particular solution, he will go for
High
multiple
level of test.
confirmations. Yes, multiple confirmations to assure that the particular cause is responsible for this disease. Okay, so depending upon the risk level, also we have to choose a tool. If you are going to have a high risk, if you are going to take a risk in a process which is quite sensitive, which may be the bloodline of the entire process, then you have to be very careful. Okay. Then apart from that, okay, it also introduces the idea of progressive approach. See, you should not go for an immediate fire or trying to find the solution in a single shot. That may be the temporary way of finding the solution, cause and the solution. So we are going for a progressive step-by-step approach. So, okay, start with simple tools, then move to structural tools, then go for analysis, analytical process, and finally you are validating using the data. So obviously that will help you to eliminate that particular cause from your process in a long-term basis. So that will lead to a continual improvement of a process. Okay, so as I said earlier, if the issue is small, you can use a YY analysis. The issue is moderate, use fishbone diagram. The issue is complex, go for FMEA, failure mode and effect analysis. Guys, are you aware of this FMEA, failure mode and effect analysis?
Yes.
Yes, some of you might be aware of, some of you might not be. It doesn't matter. We will deal
Heard
with
about it, sir, but not known in detail.
It depends
Okay,
on the
great.
Yeah, yes,
process,
sir.
like
Yeah.
the
Okay,
design
then
phase or process phase. Yeah.
then we can use some statistical tools. Why it is called statistical tools, guys? Anybody? Why it is called statistical tools?
Because it involves analyzation of statistical
It's a
data.
data-driven process.
See,
Specifically,
actually, everywhere there is data. You people will be doing a lot of data collection in the company. Every day, suppose if you are a manager or if you are in any higher designated positions, supervisors or team leaders or assistant managers, you will be getting a lot of data through mail and through hard copy papers. So, suppose if you are getting a data for 1 day's info production or quality issues or 1 week or 1 month, it is difficult to read out through, right? It is difficult to go through it completely. So, statistics. Normally, we are going to use statistical features, descriptive statistical features. See, in lower forms of the classes, and if you are in engineering, you would have studied mean, median, mode, standard deviation, kurtosis, skewness, standard error. All these are statistical features. So, what we are going to do is we are going to extract the statistical features from the data which you have and substitute in certain tools, statistical quality to control tools or statistical process tools, statistical process tools or statistical improvement tools. So you are able to analyze the data easily and you are able to find out the core of the particular data easily without much reading or much calculations. Okay, for example, there are nearly how many people in the team? There are nearly 32. So if, for example, I conduct an exam and I took the average and say, dear participants, the average of this class is 65%. So it is able to give me some real understanding about the performance of the class easily instead of going through everything, right? So this is how we are able to use this data. Okay, so data cannot be used as it is. So we need to convert them, modify them, manipulate them into some way so that we are able to understand the crux of the data easily. So when it comes to complex issue, you can use this FMEA and statistical tools. So altogether, this root cause analysis, okay, is not a single step, but it is a travel through which you have to carry this process in an effective way. Okay, so any questions or any questions or queries from your side, guys? So you can feel free to ask.
Excuse me,
Okay, no question.
evening.
Yeah.
Yeah,
Okay.
my
Now,
point is on that in the statistics, as you said, do you mean to say that statistics are tools which are used to bring out some representation of a pool of data?
for example, if you have the details of 100 employees in your company, you are you may be general manager or a manager. If you have to go, if you don't have to go through each and every data, but if I don't have any other option, it will be consuming a lot of time. So what will you do? You will look for some representation of the data, which is quite accurate, which will be also representing the entire population. That is what we normally used to do, right? So the statistical tools, the statistical methods, they help you to understand the data in a brief manner, easily. Briefly, okay, using the statistical features like mean, median, mode. What is the range of the data? Okay, for example, the age. The age has to be in between 40 to 45 for this job. Yeah.
I'm in agreement with what you're saying, Dr. Ravi. My point is, I do understand that when you have a pool of data, it's pretty difficult to go through each one of them, and it's better to have a representation on the whole lot. That's fantastically fine when you talk about 100 employees or a class of or a pool of students or in a particular course. But will such methods be appropriate when we apply to a different set of data, maybe in a hospital? We cannot go with averages, right? In a hospital, with the parameters being different to each individuals. Do we have any particular framework in which we can
For
decide what
example,
kind of a statistical tool can be used for what kind of, what set of analysis.
let us take control charts. Control charts will help to identify the variation, the reason for the will help you to identify the variation that occurs because of abnormal causes in a process with this help of statistical features. See, for example, I will bring an example from your word itself. See, for example, there are 10 patients who are visiting a particular doctor. Okay, the doctor has advised them diet, exercises, okay, then medications, and some other regular activities, lifestyle change. So every day, for 30 days, all the 10 people, lifestyle changes or food, diet, medications, this exercises is recorded. Yeah, at the end of the 30th day, on the 31st day, if the doctor wants to know if anybody has deviated from it, simply an X bar S chart can do it. A single X bar S chart, that is average and standard deviation chart, can identify has anybody deviated from this particular any one of the activity. We'll be able to do so. So instead of going through all the 30 days data, it is easy for the doctor to identify particular person who has deviated, who has deviated from the regular activities which has been prescribed. So he may call this particular person and ask, give a counseling and find out the reason, and he may advise him to follow the procedure or SOPs which is advised properly. Got it?
Yeah,
So it can be
I got
used.
the point. Fantastic. That is the way to do it. I'll take just a minute and not more than that. You can continue with the class. My
No
point
problem.
is,
You go ahead.
is it? Should I understand this to be like this particular tool is applicable in such a scenario? Do we have a framework which can guide us through, like what kind of a problem can be used in which kind of which tool can actually help us through the analysis? For example, as you said, for each of the patients, we have closely monitor the parameters. You can find out which one particular patient has deviated, and the variation is going to tell us the facts. In that way, if I have a pool of 100 employees who are working daily, and if I have data of Blue Book or something on their work styles, on their things, and if I have to run a similar chart as run for the health, will I be able to find out the particular employee who's not performing well, instead of going for an overall look at the framework and say, the entire pool of employees in the shift are not doing better, doing well, and whatever, to come out with the fact of for each of the individuals? Can we use a chart as you use in a health platform or a health scenario? Can we use, like a hospital, can we use this in a production line?
Yes, obviously, you can go for shift basis. You can go for employee basis. See, depending upon the data, you can use depending upon the availability of the data, you can extract the features, you can use it, and you can identify what is your need. For example, if you want to identify the poor performance, you need to identify what are the data you require, what are the key parameters you require to identify the poor performance. If you want to identify the rejections that are happening, okay, apart from that, sometimes you have to be very careful with the sampling also. Depending upon the population, see, if it is very difficult to, for example, if 1,000 employees are there, then if the number of components manufactured are too much, it is very difficult to collect the data from every level, everything. So you can go for sampling. See, then the sampling must be done according to the population numbers, according to the total population. If the population is high, then you have to choose sampling numbers accordingly. Then only it will be a true representation of your entire population. So from that, you can derive what kind of data do you need, and whether the analysis of this data will help you to identify what do you want. Okay, control charts. There are many types of control charts: X bar R, X bar S, IMR, C chart, U chart, NP chart, P chart. So depending upon your data availability, you can choose the right control charts, which will be a validation tool for your cause identification,
Sir,
or for
Manish
confirming
here.
there is a, yeah.
I'm sorry to interrupt you. Just want to know if there's any document or table that can represent, which method to use for this scenario, for which, I mean, kind of a set of different information and what method can be used. Just
We
for
are going
reference.
to see. We are going to see these tools. Okay.
Great,
Yeah,
sir.
So
Vinesh,
actually, there
thank you
is
on that.
no
I too actually wanted that.
Yeah,
I too
because
was actually
see,
looking
because
for it.
based
A
on your
framework which
knowledge,
can guide us.
sir, Ravi Kumar, sir, based on your
yeah.
knowledge, when you look at the data, you understand which analysis, which method to follow. But as a layman's perspective, if you just look at the data, you might be confused because you have so many methods to follow, right? Fishbone, Pareto, stratification, all these things. So the person who is actually new to this may be wondering, which one to use, and he cannot go and ask it, right? So if you have a document or a table, something to refer, okay, for this one, you can use this. At least we can try out, right? So that's my
Yes,
question.
Vinish. There is a information in front of you. You are not a layman. Anyway, you if you say that I won't agree. You people are having
No,
sufficient
just
knowledge in
three
the
days old,
process,
right?
right? See, even if you have 1 month knowledge, if you get into the industry, the knowledge
A
which you
month is
gain will
okay,
be,
sir, but this is just 3 days.
oh, you are 3 days old. Okay, okay. So don't worry. See, you just look at what is in front of you. See, the problem is quite very simple. Okay. For example, every day in our life we face different problems. The problem is
No,
simple.
Mr.
We want.
Barani's question was actually was quite you can think about it because he's looking at a different perspective. See, for example, you have a set of data, you're following this one, but when some situation you might be having a different data, then you must be sitting and wondering what to do with this one, which method to follow. Everything would be
Okay.
of
See,
similar
for
thought.
that purpose only, you have the problem is simple. Okay. If the problem is a not recurring one or a chronic one, okay, then you can use 5i. That is what is simple
No,
tools.
that is very
That's
simple because that's anyone normally use this. Very
uh,
simple.
okay.
Why?
When you need some kind of okay stratification, that is analysis to the core. Okay, some additional data can be, if the additional data is available, then you can go for this wishbone diagram Pareto analysis.
Okay.
Okay, when you need to identify any problem in your process flow is something different from regular problem, right?
Steps, as
Then,
in how you
yes,
follow it. Yeah.
then mapping techniques and other observation tools can be used. See, when you need to confirm that this is the root cause, when you need to ensure the top management that this is a root cause, you cannot simply say it is a root cause. You need to provide a validation. What is validation? You make a claim, yes, this is a root cause, but I need to ensure that the data also supports my claim. That is validation. For that, you are going to use the statistical methods. So, depending
Absolutely.
upon the, yeah,
Yeah, I'm in total agreement with you because the statistical data is what that's going to help us. That's going to help us, table our opinions, our suggestions, or whatever our decisions or the causes that we are finding out. That is absolutely acceptable. My only thing is, do we consider the purpose for which the root cause analysis is being done as one of the parameters to actually look at? As you said, we'll have to have an approach. So, what do exactly I want to find out from this? What is my assumption? Are we going to step in with a hypothesis based on which we'll have to choose a particular tool which is going to get us close to that? Should that be one of the parameters to approach a tool? Apart from data,
yes,
of course, with data there are many things that we can do with chart and many things that we can do with available data. Knowledge about the problem, of course, we understand this is the area, but what do we exactly want to do with that knowledge and with that data? Should the purpose be considered as one of the main parameters to look at the chart?
yes, guys are able to, are you there?
Yeah, and
Hello,
there.
guys? Okay, all of a sudden you got disconnected. So I was sorry.
No, I just completed. Sorry. Over to
No,
you.
no,
Okay,
no.
guys. So we are in the very beginning of this journey. Okay. So
Between is not
when we are
disconnected.
progressing, we will be using these tools. So at the time, you will be able to understand what kind of data is required for a structural analysis and for a process-based approach and for a validation. So when we are not going to just speak and finish it, we are going to see every tool with the examples. Even we are going to draw this fishbone diagram in Minitab. Right, guys? Are you okay? Sorry.
That should
Okay,
suffice.
sir.
Good.
Okay, so we are going to do that. So at the time, you'll be able to understand what data is required for what kind of stages and approaches. Okay. So now we go for this Gamba. Yes, some of you might be aware of what is this Gamba. The concept of Gamba, okay, it came from the lean philosophy. That means we are going to the actual place where the job is worked out, where the value is created, where the service is done. Okay, instead of sitting in the AC rooms and speaking over dashboards, we are going to walk into the workplace, into the service area, okay, where value is added or value is created using a process. So in industry, we normally used to say the shop floor, production line, service desk, okay, or any other place where the work is happening. Okay, so we are going to the place where the work is happening and we are going to observe directly at the source rather than relying on reports or assumptions. That is Gamba. Okay, go and see the real process. Okay, that is Gamba. So in many organizations, in most of the organizations, decisions are made based on dashboards and data sheets. But why can't we go and observe the what the real data is about? See, TPS was very successful, guys. Why? Because there was regular meetings on the shop floor. Gamba was there. That is why TPS was successful in the 1960s by Toyota. Okay, they were able to produce what the customer needs in the shorter lead times. Okay, in a reasonable price. And apart from that, their efficiency was also good because so many Gambas were there. Okay, so let us look into it. Instead of making decisions based on dashboards and data sheets, let us go for direct analysis, okay, of which hides the real issues. See, most of the decisions which we make based on only dashboards and data sheets may not be helpful for you to identify the real issues. See, for example, a report may be showing high defect rates, but only a physical visit can reveal that the technicians or the operators or the programmers are working in poor conditions, okay, which is not supporting them. Then what will you expect out of them? Defects. So that is what Gamba will do to you. See, this Gamba will ensure a real-time understanding of the process. See, let me throw you a very simple. How come a president knows what is a real scenario in a war front? Until and unless he is a soldier or he is a commander, he cannot imagine what is to be like in front of the war front. Okay, so the Gamba ensures you to get a real understanding of your process and identification of hidden inefficiencies. And also it encourages better communication with the operators. Okay, so you are able to get into the root cause identification correctly, more accurately. Okay, rather than assuming certain causes, you are able to arrive at the root cause because you have physically caught the particular root cause on the shop floor. Okay, so a Gamba walk will help you to identify that. Let me pull the same example. In a machining industry, in a CNC machining, tool breakage is happening. Okay, it may be a reason of a poor parameter issue, but when you do a Gamba walk, you found that the coolant is not reaching the cutting zone properly. See, the issue is something else, but the data shows a different output. And obviously, we may be thinking very high about that particular defect, and we may be assuming and deciding a root cause. But when you do a Gamba, you are able to identify that the root cause was a simple thing. So Gamba really helps you to identify the real causes of the problem. Okay, so the how you execute this Gamba work. This is a structured visit by engineers or supervisors or managers to the workplace. Guys, remember this is not an inspection. You are not going to inspect, measure, or do anything. You are just going to observe and learn. Okay, an observational and learning activity. Okay, so how to execute this?
Sorry to interrupt, sir, but
Yeah.
this is supposed to be done only by the leadership level team. Am I right?
Sorry, you are. It is going to be done by the. I'm not able to read it clearly.
No, the Gemba actually, which is mainly meant for the leadership level team.
You are saying it is for the team.
No, no, no. What I mean to communicate is that, no, is this particular process, the Gamba, which is supposed to be demonstrated only by the, I mean, at least at the leadership level, management level team. Am I right? Not for everyone.
Not only management. See, if you see, for example, you may be a manager or you may be an engineer. So if a problem
Your
comes
voice
to
is
you,
not audible, sir.
my voice is not audible.
Yeah, now audible. Yeah.
Okay. If you see, you may be an engineer or a manager. So if your problem is regularly coming to your desk in the form of data, instead of deciding from sitting there itself, you just go for a walk. Just go for a walk. Don't inspect anything. Just observe where these defects are happening. Okay, what are the conditions? How the operators are executing. You just go for a slow, gradual walk and try to observe and learn. Okay, because you are receiving a report, you are receiving a data. So
Sir,
that
is it
means
applicable for every industry or just a mechanical?
every industry can do it. Yeah. See, for
No, no.
example, if you take an
My,
institution,
no,
you take an
my
institution.
query is that
Uh,
Gamba is supposed to be done by the staffs or the executives whom they are representing the management level. I mean, am I right on this?
yes, it is right. But if you are the guy who is responsible for answering the top management, then you
Correct,
have to
correct,
make the work.
correct.
See, you
But in that case, how can I mean, how I'll be going to the workplace without any kind of agenda? As you were mentioning.
Sorry to interrupt. I think Ganeshwaran, right? So first task is Gamba work can be done by anybody if it is allowed or facilitated. And as per the agenda setting point, the agenda is already set. You are already know a problem and you're going to see why it is happening. At least that is what the process is for me.
okay? See, if you face the problem, if you face the pain, if you are the one who is answering the losses that is happening in your process, why can't you take a walk? You may be an engineer, you may be an executive, you may be a manager, or you may be a supervisor.
So this is
You may
just
be a,
a visit to the particular site and investigate yourself. That is it. Yeah.
yes, do not even investigative, just go and observe and learn.
Yeah. Why
Ask
this is
simple,
happening? Why there's a problem? If there is a certain problem in certain area, you go to that particular area and see and then talk to them and why this is happening. So that's simple.
yeah, obviously. You just interact with the operators more politely and ask them how things are going. Don't ask them about the problem. Then they may be aware of something is wrong. Just ask them, observe the conditions. Okay, interact with them politely. Okay, try to identify the deviations that is happening from the standard practices. See, sometimes they may be doing work without proper safety gears because they will say that we are able to do work easily without the safety gears. But at any moment in 1 year, if one accident happens, that may be a bad remark for your uh, career or for your particular department. So you may be able to identify bad practices, deviation from standard practices. Okay, and you'll be able to observe a lot of things when you go for a walk. That is what we are trying to do in Gamba. Okay. See, for example, if you go for a walk in an automobile industry, see, workers may sometimes skip certain steps, certain activities to meet the production targets. See, recently I had a real-time example from one of my students. So actually, I am coordinating one of the largest industry in India. Okay, which is
Crosstalk is going on.
I
yeah, I
think
am
he's
having a lot of background noise.
Some crosstalk is there.
no, it's someone is actually watching cricket match.
Yeah, guys,
Oh
please
my
mute it.
God.
Yeah. Please take a brief walk out of the cricket. Okay, so listen. See, actually, I had a experience with one of the industry guys. So actually, I am coordinator for one of the industrial programs where nearly 200 of my students are working in industry. They are employees, and coming and learning in my university. See, and recently I spoke with a guy and he said, sir, I was suspended for nearly a week. I asked why, sir, in order to meet the production, we have skipped certain steps. What he did, in order to, but actually that step was not required. Okay, but since it is of not great importance, he decided he could skip it. So the entire team, they have keep on skipping, not the single person, guys. The entire team, they skip a particular step, and they were able to meet the production. At one moment, they were exceeding their target. So on one particular night shift, this guy was doing that, and a manager walked in and he found out. This is Gamba, guys. Okay, and all guys escaped. He was cut. He was suspended. So actually, there is one of the important companies which manufactures this suspensions, brake assemblies, steering, everything for all automobiles in the world. Okay, so this Gamba work can help you to find this kind of things. So which you know it is important, but the operators and the technicians think, okay, it is for them production schedule, production target, and all these targets, tasks are important for them. Skipping activity, if it meets, if it helps them to reach the production, then obviously they will do it. But you cannot allow them to happen, right? So that is what Gamba can do to you.
Where are you working, sir?
Actually, I am working in Chennai in Crescent University.
Where, sir?
In Chennai, Crescent.
And Crescent.
Yes.
Yeah, BS
Okay.
Abdul Rahman University, correct?
Yeah. So you guys are from different parts of India, right? All over India.
Yeah, I'm from
Yeah,
Kerala.
and some of them are attending away from India
Oh,
also, abroad.
great, great, great. So Gamba may look like an outdated thing, but actually it is not so. It is important that we go for a walk once in a while. If you have some frequent updates about any problems, or if you are receiving frequent mails or data about a particular chronic issue, it is good. You go for a walk. Just be an observer. Don't be an investigator. That is an important thing. Okay, if you are able to find out anything specific, then obviously it will be more confirming. Okay, so many things may be asked. You are looking in a, you are observing in a point of investigating. Okay, but not investigating anybody physically. That is the important thing. Okay, so
Yeah,
Gamba
I
walk is quite.
understand. I understand the importance of Gemba, but it's something pretty new to me because for a change, I'm also right now from Chennai, but my background is from the military. So something this is completely different. And in military, we don't go for Gemba walks. It's completely different there. So it's an eye opening. Thank you. Go ahead, please.
Okay,
Sir, sorry to
so when you,
interrupt. I have one
yeah,
more query on this. Over here, actually, we are discussing about, I mean, the tools which can be dealt for this root cause analysis. Am I right? So in this
yes,
case, a top man or as a responsible head of the department, and I already have the data also, and I'm already aware about the problem also. So I'm unable to conclude that, like, actually what is the intention behind, I mean, without any kind of agenda or preparation, why I'll be doing this exercise. Because actually, see, before going over there, I mean, there is no preparation at all. Like exactly what is the intention is planned at.
see, actually, as I said earlier, most of the organizations decisions are made as per what you said based on data sheets, and you have sufficient information. See, why? What is the problem? See, we are trying to find out the root cause and we are trying to analyze it. So, what is wrong if a manager or an engineer or a uh, supervisor goes, team leader goes for a walk once in a while, not regularly. If he goes regularly, then he will become a supervisor, the manager. So once in a while, if he is getting a continuous information that this particular defect is arising, or this chronic issue is happening, or this problem is coming from this particular department, why can't he go for a surprise visit?
Yeah,
See, you
can
are
be considered as a first step of finding root cause.
See, we are not trying to investigate. That is what you are not going to investigate. Just go for a walk. Even
Yeah,
general managers of all companies, Japanese, they used to go and interact with lower level hierarchy people. That
correct.
is what is missing in Indian companies. In India, so many dead-ass theories are being followed. That is only downline hierarchy. We are following a long hierarchy, and most of the times We are not able to understand the ground level issues because there is no direct communication or this kind of gamba, which will help us to identify the real ground level root issue. Okay, but Japanese, they used to have a ground level communication. Even the topmost guy used to come then and there and he used to interact. Okay, so it is not bad, it is not wrong, it is good, obviously. If you go for a walk once in a while, because you are working for this company, you are making decisions for this company, why can't you go walk once in a while?
Understood,
Not
sir.
regularly.
Understood.
Sir,
Let's proceed.
apart from this manufacturing industries or other industries, is this Gamba useful in software industry for process improvement, process enhancement, and to find the root cause of all these things, the process and all?
Just go for a walk in your floor. It will sometimes motivate your employees, sometimes you may notice something.
Correct.
Okay, employees may not be in the seat. Okay, during a regular working hours, employees may be in the restaurants or in the cafeterias. Okay, employees may be playing, employees may be using over usage of mobile phone. You can identify anything which may be the root cause for a certain problems. So wherever you are, just go for a gamba once in a while. It will create a different atmosphere altogether. And apart from that, you can observe certain things. You can identify certain things which are away from standard practices. Okay, wherever you go, this happens because human mindset, human culture is like that. Okay, we always look for some kind of space when we get some chance. Okay, so if it is happening occasionally, see the condition which I am putting you is if you are having reports about frequent issues, problems, chronic things, then go for a walk. If you are getting data in a well efficient manner, okay, no problem. Why you need to go for a walk? If you are getting data regularly, mails regularly, frequently, that something is wrong. Some efficiency problem, effectiveness problem, delivery problem, delivery date not met out, then go for a walk. We are not going for a walk simply to waste your time because your desk is having continuous information about certain issues, problems, and the root cause is identified based on some data. Is this data correct? Just go for a walk anywhere else in the process industry, in a paint industry, in the automobile industry, in the inventory industry, in the logistics, wherever you are, in a hospital, in a hotel management, you go for a walk. You can identify something new which is not present in that particular data. There is a possibility. So why you miss it? So we want to ensure that the root cause is identified accurately. Accurate root cause identification only can help you to go for a correct solution. That is what we are trying to do. Got it? Still, we have a lot to discuss, guys. Okay, let
Yes.
us take the walk. Okay, so Gamba walk is one of the techniques. Then time and motion study. What is time and motion study? See, without knowing about the process, how come you improve the process? How come you identify there is something wrong in the process? So the time record for for example, if a process may be having 25 activities, 30 activities, 50 activities, you need to use time and motion study, which helps you to record the time taken by every activity and the movements made by every worker or employee for that activity. See, for example, if you look at the keyboard doesn't have the alphabets in the particular order. It is having in a different manner, right? You have a large space bar. Okay, you have enter in two places. Why? Why, guys? I believe Shankar is from software industry, right? It is a simple question, but Shankar will be able to give you more better accurate answer, right? Why do you have like this? Because you will be using those particular keys again and again and again. So if the key is very small, then obviously every time you have to search for it. So if you just have a large space bar, okay, you don't have to search for it. You don't have to look for it. You just can touch it and move to the next word or coding or strings. So movements of the workers also must be recorded. Okay, actually it was done by Gilbert, a team of people, team of scientists called Gilbert. Okay, they started recording the movements of workers by putting lights on every fingers, so that if any extra unwanted movement is done, okay, if they are doing it 2 seconds, if the unwanted movement is conceding you 2 seconds. And if they are repeating the same activity thousands times, imagine 1000 into 2, 2000 seconds are being wasted. For example, in printed circuit board manufacturing assembly, in mobile manufacturing and assembly, they are repeating the same activities thousands of times every day. In automobile industry, in software industries, in desktop typing, okay, in documentation industries, in patents. See, sorry, not patents. Okay, say they are repeating the same activity again and again and again in certain process industries and all. So if they are doing one unwanted activity which consumes them 2, 3, 4, or 1 second, then obviously that is a wastage. That may be the cause for the poor process efficiency. We need to identify that. Non-value adding activities, unwanted redundant motions, process delays. It's so the time and motion study will help you to find out the time taken for every activity that is being carried out in your process. Okay, even it may be a software testing, or it may be a calibration process, or it may be a diagnostic process, or it may be a racking of components, child parts, or finished parts, or semi-finished parts in an inventory store, warehouses, in a production process, or in a quality process, whatever it may be. So time taken for every task must be identified, and movements of workers must be captured. Okay, that is called time and motion study. So before going for a time and motion study, you have to be very careful what process or for what activity you are going to do that. Because that activity must be somewhat value. Without having a, if you are choosing time and motion study for any activity which doesn't have any value, there is no use in that, right? So you have to choose a time and motion study for the process which is having sufficient value in your organization. Okay, because it is a long process, it is not a short process, so you have to do it step by step. So you have to choose that, you have to choose a process, and you have to evolve the correct time measurement methodologies, stopwatch, or so many measurements methodologies are. We don't have to speak about it too much. So time has to be collected, and the movement of workers also has to be studied. Okay, that will can help you to identify non-value adding activities in a process. Process mapping, non-value adding activities needs to be identified, because that may be the root cause for inefficiency and more problems which is coming out of your process. Unnecessary movements, wasteful movements, process delays. Okay, see, for example, why we are implementing 5S, guys? In most of the organization, there is 5S. We know where the tool is, we know where the ledger is, we know where the system is, we know where the software is present in that particular desktop, we know where the particular Excel file or Word file is saved in the particular desktop. All these are part of avoiding, eliminating non-value adding activities and unnecessary movements. Either it may be given to the fingers or to the physical worker. Okay. So time and motion study is one of the important techniques which will help you to identify the time taken for every task and to reduce, eliminate unnecessary movements or activities that is present in your process. Okay. Then video analysis. What is this video analysis? See, for example, in high-speed machining or in certain areas where the process takes place at very high, quick time, in a very quick time. If, for example, certain activities, it will take only a fraction of seconds to get completed. Okay. So you won't be able to understand whether it is carried out correctly or whether there is any flaw or error or fault or deviation in that. So if you want to find out if you want to analyze those kind of activities, okay, then a frame by frame analysis is required. So in that case, you have to go for a detection at micro levels. So that is where we go for this high resolution video recordings, and you'll be able to do it frame by frame. Okay, see, for example, there was a new technique called vibration analysis. Okay, that is acoustic analysis, vibration analysis, and all is being carried out in machineries, in most of the machineries, any kind of field. They are using it using machine learning and this deep learning. That is, the machine vibrations are captured using accelerometer sensors. Okay, accelerometer sensors are used to capture the vibration of machinery, and they are compared with regular, better operating conditions. And if any fault or any maintenance issue is going to occur in next 6 months or 3 months can be predicted in advance. Okay, so like this, the video analysis also helps you to identify any flaw or fault which is happening in the particular process by analyzing the frame by frame or high speed cameras which can capture the activity in a microsecond by second, and if anything wrong is happening then you'll be able to find out using slow motion. Okay, so this is also a part of the analysis, video analysis. It is very rarely carried out in certain area. Then you know about this 5W and 2H. It is also a structured questioning method which ensures you get the complete understanding of the problem. So 5W, what is happening? First W stands for what is happening, why it is happening, where does it occur, when does it occur, who is involved, how does it happen, how much impact is happening because
Sir,
of this.
yesterday it was mentioned as 5W1H.
Okay, you can increase it. Now you are increasing 1H. Okay, how much impact? Because we are going to see the impact matrix here. Okay, how much impact this particular problem has created? Okay, what is the impact of the Strait of Hormuz? How much impact the Strait of Hormuz has created? 20% of oil supply is disrupted all over the world. Okay, so one more additional data which can help you to find out the cause of the problem. Okay. Similarly, for example, in a software support ticket, why the tickets are delayed? Let us take a software support system. You may raise a question like this: why the tickets are delayed? Where is the delay occurring? Who is responsible? So these kind of leads will help you to identify the bottlenecks, and you'll be able to eliminate the bottlenecks and increase the efficiency, speed, and execution of your process. So altogether, the Gamba helps you to differentiate, okay, real versus assumed, forecasted, okay, predicted problems. See, we predict some problem and we have a fixed mindset that this problem is occurring because of this thing. But if you go for a Gamba, you are able to identify the real reason. Then only we ourselves will accept it. Oh my God, this is especially the reason. Okay, and it helps to improve. See, it is one of the add-on factor which helps to improve your decision-making accuracy. See, we are not, guys, please remember, we are not going to make decision based on Gamba alone. Our efficiency improves, that is, our accuracy of decision-making improves because of this Gamba. So, if the general manager is going on a work floor or a software manager is working on a floor, then obviously the employee involvement will improve, will enhance, right? Okay, so it helps to eliminate the waste also by identifying unnecessary movements in time as well as in motions also. The thing you must understand is, some of you raised it quite nicely. Most of the times you don't find top management executives, you don't find time to make a Gamba. Okay, you are occupied with heavy documentation and other analysis and meetings. So it is obviously you have some difficulties because if you have to sometimes in certain flows, if you have to make a walk, it will take you half an hour, 1 hour. Most of the times you don't have. So there are some issues, and apart from that, you need some real skill for observing things. I believe all of you will agree with me, right? See, for example, if a mechanical engineer walks in a software floor without having sufficient knowledge, he won't observe anything. Only a software manager understands everything. Software engineer, if he walks on the mechanical assembly floor, he won't observe anything. He will just see what people are doing, but he can't understand major deviations, minor deviations. But a software engineer who is expertise in that area only can observe. So skill is also required for observing. Okay. So this kind of plus and minus are present in the Gamba. So any questions, guys? Okay. Now we go for this affinity diagram. That is my, okay, here it is. Guys, what is brainstorming? Different types of brainstorming. What is brainstorming? See, we are trying to generate the causes, okay, which is the foundation for the root cause. See, we doesn't know. For example, Let me give you a very generic example so that everybody can understand. See, for example, you are having a coffee. The coffee doesn't taste good. Okay, what could be the reason for the poor taste of the coffee, guys? Yes, come on. What could be the reason for the poor taste of the coffee?
Roasting of the
Less
bean,
sugar.
Yes, less sugar,
roasting
sugar.
of the bean.
Okay, then the coffee seeds are not roasted properly,
Not appropriate temperature.
not sufficient temperature, either maybe high temperature or low temperature, high content of water, low content of water, high content of milk, low content of milk. Okay, then high content of sugar, low content of sugar. See, this kind of idea generation using causes. See, we are trying to generate causes. See, we are not trying to straight away pinpoint that this is the root cause. That is not at all our idea. We are trying to find out all possible causes that may be related with a particular problem. See, we are trying to find out the correct root cause using analysis. That is RCA. But what is the foundation for that? You need to identify all possible causes that is connected with the particular root problem. Then only you'll be able to identify the root cause. So we use the brainstorming to generate all possible causes which may be responsible for the problem. So it is essential, important, critical that you identify all possible causes, and brainstorming will help you to do that. So this brainstorming is a creative and a team process, collaborative process, where every team members must contribute, okay, uh, democratically, freely, without fear of criticism. See, for example, if you have a team of doing RCA, and the team compromises the top level management guys and the medium level guys and the lower guys supervisors also, the supervisors will be having a hesitation here to speak out what they know, even though they may be having sufficient knowledge about the process. If the general manager is on the opposite side, definitely they will have some kind of fear or hesitation to speak over the particular forum or the meeting, right? So the brainstorming must break that. You have to participate freely without any fear of domination or criticism. That is how the brainstorming can be successful. That can be helpful for your RCA. So the brainstorming must ensure that all the perspectives of that particular problem are considered, especially in complex problem where many departments may be involved. There are certain problems which many departments may be involved. There are certain problems which only one department may be able to handle it, control it, resolve it. But certain problems may be in connection with the R&D, production, quality, procurement. So in this case, you need to ensure that the brainstorming is conducted in a free and fair manner, where there is no suppression of participation or criticism. Okay, then only you'll be able to get the outcome of the brainstorming, and your brainstorming will be effective. Okay, so the brainstorming can be conducted in a structured and a unstructured manner. What is structured manner? That is, you have to ensure that all participants are able to express the views without any difficulty, without any fear, without any fear of criticism. Okay, suppose if one or two participants are dominating the entire session, like what we are seeing in television shows now, then obviously your brainstorming session will not be as effective as it is as you want. So ensure that the brainstorming is conducted in a round robin method in a structured manner. So all participants which you make participate in the brainstorming are able to give you their expertise and knowledge and share their ideas in the brainstorming forum. Okay. So always prevent bias, generate a wide range of possible causes using the team, ensure that only relevant people who are aware of the particular problem, who are aware of this particular causes and issues are present in the meeting, in the brainstorming. Okay, if you are pulling people who are not connected with the problem or not facing the loss or bearing the pain, they will discuss something else which is not wanted unnecessary. Then obviously the entire brainstorming will be hijacked. The discussion will be hijacked, and you will be ending up with a zero productive session. A wastage of time. Okay, so you have to ensure that okay, uh, proper utilization of team knowledge is happening there. Okay. So, for example, let me say in certain cases, For example, take um, certain examples. Example, in a production floor or in a software testing floor or in a hospital, some people who are having more experience will be having clear-cut idea about the reasons, causes. So if you pull them in this kind of brainstorming, and if the brainstorming environment climate is not encouraging for them to speak, then obviously they will remain silent throughout the session. Then obviously your effort will be wasted. Okay, your effort which wants to get the reasons for the particular, which wants to get the causes for the particular problem may not be effective. So you have to ensure that people who are relevant, people who are having sufficient knowledge, even you can pull consultants if required. There is no wrong in that. Okay. So you have to ensure that sufficient people with good knowledge, expertise in the problem are present in the brainstorming. So when it comes to types of brainstorming, you have different types. Silent brainstorming. See, whenever it is difficult to control the team of people, you can go for a brainstorming. The participants will write the ideas individually. Okay, and they will submit to you or they will send to you in mail or whatever it may be. So this kind of brainstorming will help you to avoid dominance or criticism or bias. And apart from that, if the brainstorming is conducted in this manner, everybody will be sending their ideas or participants, right? See, for example, let us take a software company. Software team, the junior developers may not speak. See, for example, we have a participant, Virish, right, who is having 3 days of experience. Suppose all he's just having, he said he had only 3 days of experience. So this he's in the initial level. So sometimes people in the initial level may hesitate to speak. Okay, so but if they are allowed to contribute to this kind of written ideas like silent brainstorming, they will be very happy to share their ideas, and their ideas also will be considered. So silent brainstorming is better than open brainstorming. That is what we used to conduct normally. That is discussing, okay, encouraging the interaction of the participants with everybody else, okay, and building on their ideas and finding out the causes easily. Okay, so the silent brainstorming and open brainstorming can be conducted based on your need. Okay, then affinity diagram. You are just seeing an image of an affinity diagram. So it is one of an excellent quality management and root cause analysis tool. Okay, so it is one of the excellent way of identifying the root causes. Okay, it is used to organize large number of ideas, okay, into groups, into categories based on their natural affinity. Okay, based on their affinity. See, for example, during brainstorming, you may be coming up with 50, 60 causes. If you read one by one, you won't be able to find out anything easily. But if you categorize them, if you segregate them into groups, you'll be able to understand it easily better. Right? So after brainstorming, where the team generates many possible causes, and they need to structure them in a meaningful, understandable manner. In this case, you have to use this affinity diagram. Okay, so the main purpose of affinity diagram in our RCA is to bring clarity to complex problems by segregating them, classifying them, grouping them, okay, into categories. So, for example, 50, 60 causes may be there. Some may be connected with manpower, some may be connected with testing, some may be connected with marketing, sales, research and R&D. Okay, so you have to group them so that at the end you are able to see it in a more more meaningful manner. Okay, so and you are able to understand the complexity of the problem. You are able to understand the core of the problem easily. Understanding is important. Okay, so and apart from that, it helps our RCA team to identify the patterns and our relationships and major connectivity among those causes, making the analysis easier. See, if you are able to list out the causes under man, under machinery, under testing, under marketing, under sales, under coding, and purchase, then you are able to find out the relationship. Okay, whether some certain causes are occurring more frequently, then some pattern may evolve within that. So you are able to understand all these things using this affinity diagram. Okay. So see, in organizations, in any companies, problem solving, especially in industries. Okay. See, this brainstorming, as I said earlier, will produce dozens and dozens of causes. Okay, so without sufficient organization, without sufficient organizing the data, it becomes confusing. That is why we are going for this affinity diagram. It will be confusing when you write the outcome of the brainstorming. You may be having hundreds of causes. You may be receiving some 30, 40 mails. Each mails may be having 4 or 5 causes. So altogether, you have 120, 150 causes. So this affinity diagram helps to convert this unstructured data into a structured form. So we are able to identify the hidden relationship, which will help you to support decision making, and it will help you to prepare tools like fishbone diagram and FMEA. That is why we are here. So making a fishbone diagram from brainstorming and this affinity diagram is quite easy. It's very, very easier. Okay. So here itself you can see you have a small issue, right? Small issue of brainstorming. A tool wear. We got these ideas from brainstorming. Tool wear. Okay, vibration, gas of coolant issue, dust, improper feed, lack of training, operator fatigue, wrong inspection. Okay, and tool breakage. Tool breakage is happening because of this poor materials, high temperature, humidity. All this came out of the uh, brainstorming. Let us say silence brainstorming or open brainstorming. The reason, the effect is a surface defects. A surface which is machined is having a lot of defects. So these are the causes which are identified by the team during brainstorming. So if you categorize it, if you segregate it, if you classify them, if you group them, you are able to understand more machine. So because of machine tool wear may happen, vibrations, because of machines vibrations may happen, that may affect the surface finishing. Coolant issue, if coolant is not supplied sufficiently, that may also provide a insufficient poor surface finish. Okay, then method, if you are providing high speed, if you are running the machines in high speeds, then obviously you cannot expect good surface finish. If your speed is fluctuating, improper, varying regularly, okay, in a random manner, then obviously that also will lead to poor surface defect. And wrong methods. If you are using wrong methods to finish a surface, then that also will lead to. And manpower. If the same manpower is working without sufficient rest for continuously, okay, in many companies there it's happening. So that may also that can create a fatigue. Then if he doesn't have sufficient training, because of error, human error, material, if the material is not of the required quality, if the variation, okay, if the variation, that is, the material composition is not uniform, that may affect the surface finish. If there are defects in the materials, hidden defects, environment, okay, high temperature, humidity, dust, all this can be the reason for the poor surface finish, which is having defects. So if you see the old one, that is the one here, and if you see the grouping, then you are able to understand, right? You are able to understand a lot. You are getting a lot of clarity. Okay, that is what this affinity diagram can do to our RCA. Brings understanding, brings clarity. And because of that, we are able to use this fishbone diagram and FMEA, okay, easily from this affinity diagram. Okay, so that is how this affinity diagram helps you to do it. Okay, so if you want to see how this affinity diagram can be developed methodologically, that is a simple procedure. First, define the problem. Okay, conduct a brainstorming. Define the problem. That is, clearly state the problem. Then conduct the brainstorming. Okay, using silent method or an open forum. Okay, then group the causes under headings like machine, manpower, or methodology, or whatever heading you have according to your industry or organization needs or your process needs. Okay, so you can create any type of categories, but make sure it is relevant to the problem. Okay, then only you'll be able to analyze. Then analyze and prioritize. Analyze and prioritize. So identify which groups contribute to most of the problems, most to the particular problem. So that is how you can create a affinity diagram. So first define the problem, then generate the ideas using brainstorming, group them under different category headings like manpower, machinery, methodology, sales, marketing, quality, okay, and everything testing. Then analyze and prioritize which group is contributing most to the group. So that is how you can create an affinity diagram for your clarity and understanding. So any questions, guys? Okay. Now let us move to the next one. Y-way analysis or five-way analysis. What does this Y-way analysis or five-way analysis does? See, this Y-way analysis is a very simple technique. Do you know how this Y-way analysis came to the surface of industry? Actually, it was developed by Sakuji Toyoda in 1930s. Yeah, hi guys, can you believe it is a century old too? This Toyota companies, Toyota Industries, sorry, Toyota Automobile father was Sakuji Toyoda. Okay, they were manufacturing some other machineries, sewing machineries and handlooms in the earliest days. So there, the Sakuji Toyoda started using this Y-way analysis. Okay, so in the 1970s, when Toyota Industries were picking up and growing, they started using this Y-way analysis. Then it became very popular. So the concept is very simple. You use the Y, okay, to create a set of questions and you try to arrive at the cause or the root cause. Okay, so the idea is very simple. Don't consider the symptoms as the causes. Don't consider the symptoms as causes. Okay, so normally first you have symptoms, then you have immediate cause, then you have root cause. So Y-way analysis will help you to tear down, okay, this layer by layer. So every problem will have layers. First, the symptoms. Most of the times we try to provide solution to the symptoms. It is not going to clear you the root cause. But Y-way analysis will tear down this layer. First, it will help you to identify the symptoms. Then it will help you to identify the immediate cause. Then finally, it will help you to arrive at the root cause. So by asking the why multiple times, we move to the surface issues. We move from the surface to the deeper causes. Okay. For example, you can ask why the tool breaks because excess cutting force. Okay, why you are providing excess cutting force? Because incorrect feed rate. Why you are providing incorrect feed rate? Because wrong parameter setting was done by the operator. Okay, why the operator set the wrong parameter? Because he was not trained. Then finally, you can ask why the operator was not trained, because there was no training system for that particular job. So the root cause here was a lack of training system. The root cause here was a lack of training system. Okay, so also you have to remember that I already explained this five-way analysis is for simple problems and for quick analysis. And using a team, you will be able to arrive at the root cause for the simple problem easily. Okay, so this is how you can use a five-way analysis. So you must remember that it is not suitable for complex problems. Okay, it is not suitable for complex problems. So when it comes to complex problem, you have to go for the next level. Okay. So finally, the important thing is you have to stop generating why question when you believe that the action, when you believe that the cause, okay, is going to be the final one. When you believe that the cause is the reason for the particular problem, or if you feel that the root cause is the when you feel that you arrive at the root cause, you can stop there. Until then, you can continue. There is no limit to the number of why questions you ask. You can keep on asking the number of why questions, but ensure that you arrive at the root cause or arrive at the proper cause. There you can stop. Okay. So sometimes if you go,
Doctor, one small thing to ask on this.
yeah.
Like when you say, I was about to ask you, when do you exactly arrive at the final cause? So you said that unless until you feel like it is tangible to the problem, and you're saying that yes, this is something relating to the problem, so you're going to stop there. I'm totally in agreement. But is it not fair when you said, for the example, to cite the example that you took, it's like the training was not imparted correctly, the trainer was not available, and that's the basic reason for the tool getting damaged every time. This is what you said. So is it not fair to again find out what is the reason behind the trainer not being available? Maybe the HR failed, maybe the compensation was not sufficient from the HR design. So something should be a reason behind it. It is maybe another problem, but should we stop there, or should we hand it over or move it up for a different analysis, which is not having a direct impact over the process or the problem in hand, but definitely it is something to be addressed.
Yes, obviously. So when you believe that the scope has ended there, okay, you cannot go and influence the HR department. See, what you can do is you can identify this root cause, and you can write an immediate recommendation to your superiors. Okay, so that sufficient training system was imparted to candidates who are deputed in the particular machining area, so that this kind of problem doesn't occur again. It's not repeated. So lack of training system, okay, has to be a concern of the top management system, because it is a important cost of good quality issue. So you have to invest. Training is not free. Even though for the operator, for example, if you are recruiting an operator or a technician or an engineer, if they are undergoing training for a minimum of 45 days or 3 months or 6 months, you'll be paid like a regular engineer or operator, and you'll be getting all allowances and everything mostly similar to them. So it is a highly paid process. Okay, so some companies, they try to cut down this cost by putting them directly into the shop floor or into the they believe that you have been trained in colleges and diploma colleges. So if you just move here and there, and if you are with certain operators for some time, you can learn it. That is what they believe. So lack of proper training system may be the reason in this particular case. So the supervisor or the team leader has a right to the top management. Okay, you need to have sufficient training system to impart knowledge to the freshers or to people who are deputed from other departments. Then only this kind of problems may be eliminated from occurrence in the future. Okay. So that is how this YV analysis will help you to do it.
Hello,
Yeah.
sir. I have one question.
Yeah, please go ahead.
Sir, but in certain cases, after first Y and second Y, there will be a number of subdivisions of the Y. Like for the second Y itself, we will get a subdivisions of number of Ys. So how can we manage that type of problem solving?
Yeah, actually, if you have multiple causes, you cannot use YV analysis. That is what I said in the beginning. See, the ultimate condition for using the YV analysis, it must be a simple issue. It means a simple problem. If you have multiple issues, then obviously you have to collect all these causes and you have to merge it along with brainstorming, and you have to develop a fishbone diagram. Right, Vijay? So if you feel like it is having multiple causes, then obviously 5-way analysis is going to be a failure if you use it. Very simple. Okay. So let us take the next problem. So the next one is we are going to use a 5-way technique. Okay. In this slide you can see some manufacturing defect scenario where the production line is stopped due to defective parts. Okay. So the initial problem appears very simple. Production stopped due to defect parts. But this is only a symptom, not the real cause. This is a symptom. Production stopped due to defective parts is a symptom. The purpose of our Y is to move beyond the surface level. So the surface level observation, okay, is a symptoms. We are going to uncover the issue, the causes, okay, using this. Okay, for example, say the first level of question identifies that the line stopped because defective parts were detected after inspection. Okay, so this shifts from the production stoppage to the quality issues. Why the production line was stopped? Because of quality issues. The second Y reveals that the defective parts were produced due to incorrect machine calibration. So now a technical cause has arisen. Earlier, looks like defects. Then The defects were identified by inspection. Then now it looks like incorrect machine calibration. So we are getting a technical issue. Okay. Then the third why, it goes deeper and finds the calibration was incorrect because the procedure was not followed properly. Okay, so here we come to a process related issue rather than a technical failure. You are deviating from the procedure. That is why this kind of, see, what looks like a rejections, okay, then a quality issue, then machine calibration issue has now become a process procedure issue. Okay, then finally, when you go for the fourth question, you ask why further. I see when the fourth why, you are able to identify that the operator was not trained on the particular calibration method, highlighting a human cause also into this, bringing a human cause also into this. Then finally, the fifth why, we are able to identify that there is no system to ensure, there is no system to ensure that the operators are trained. Okay, when procedures are updated, see, every now and then in all companies, they are updating software, they are introducing ERP, they are installing new SAP, okay, they are introducing new tools, management techniques. But whether the operators, technicians are trained is a question mark. So obviously, this is a system failure, not just an individual mistake. Because most of the times, this is one area where they are able to identify a process failure because of an untrained operator. Most of the times, operators are not trained, technicians are not trained. Okay, for example, if you are moving from, for example, ultrasonic testing to radiography testing, some kind of sufficient training must be provided, right? If you are moving from one level of testing to another level of testing, to ensure that the process is upgraded, you have to train them. If you fail, there is a system failure, not the technical failure or the lower end failure. Okay, so this kind of analysis, okay, will help you to get to the core. But remember, guys, obviously, this is a simple issues. Okay, when it comes to complex issues where you have multivariant causes, you cannot use YY analysis. Here you have one more YY analysis, which will help you to do the root cause analysis. See, for example, see why the customers are waiting too long for support. Because call volume exceeds available agent capacity during peak hours. So during the peak hours, the call volume seems to exceed. Okay, so where does the error happening? So the call volume exceeds available agent capacity during peak hours. So this suggests a resource issue, right? There is a resource issue, manpower issue. The second one reveals that high call volume exists because many customers are calling from recurring issues. Recurring issues is repeated issues, same issue not resolved. Okay, so this shifts the focus from manpower issue to repetitions, problem not getting resolved. Then the third why helps you to identify the recurring issue persists because of self-service knowledge base. Okay, because a self-service knowledge base does not address common problems. See, it is like tutorials. Tutorials must address the common problems which occurs in the customer service, the customer side. So the tutorials doesn't address the common problems. So this indicates a gap in the support infrastructure provided to the customers. So the fourth why explains the knowledge base is not updated. There is no process to revise it based on customer current queries. So the fifth and the final one reveals the root cause. Okay, that is a root cause. Fifth one is a root cause. There is a lack of communication and coordination between the customer service and the content teams. So they simply give some solution and the customer call back tomorrow with the same issue. So this is also a system level organizational issue rather than an operational issue. So what started as an operational issue because more customers are calling has now ended up in a system issue. So this is how YY analysis will help you to identify the root cause if it is a simple issue. Okay.
Yeah, Dr. Ravi, if I can just interrupt for a second.
Yeah.
What you're saying is absolutely fine. When you go down in this stream of thinking, what about there is one way, like the customer care guys and the customer requirement and the content team doesn't actually correlate, and they are not in collaboration. So there is a gap between. This is what you're saying. I'm absolutely in agreement. But can it be like the second question itself? Why should, when the volume of calls increase, it is not that customer care service is not appropriate. It may be like, why should a customer be calling so much? Maybe the content is not user friendly.
See, the customers are calling regarding same repeated issues.
Yeah,
See,
that's
that
what
is
the customer is not able to understand. That's like it is not user friendly and self sufficiently. It is not available in the app or whatever. That might be one of the reasons also.
See, if you are able to forget at that particular reason in the second question, okay, it is. I don't think you will be able to get at such in-depth level in the second question most of the times, because step by step only we are able to reveal the issue. We are able to peel the layer one by one. See, why many calls are repeated? Because why call volumes are exceeding in the peak hours? Because the same issues are being repeated again and again. Same issues are not resolved, and it is resolved temporarily. So customers are calling back again.
I agree. I agree. My point is, I see, unless until you have already disclosed that the lack of functional collaboration is the basic root cause. Now we say that on the second layer itself, we are able to peel it out every time. It's not possible. To me, when I don't know the root cause, the second question will lead me to the third question as to how the content has been developed, why it is developed. So it leads me to there is a possibility of getting led to a different root cause altogether.
Obviously, if you lead to a different root cause, and if you find that is a viable, and that also may be the reason. But obviously, in this case, you believe that you may be getting at a different root cause altogether if you get this question, right? If you believe like that.
Yes, I do.
See, there is a possibility. There is absolutely a possibility. But if it is not the root cause, and if it is not going to address your problem, then obviously it is not the root cause. Okay.
Yeah, the point I'm coming to from here is when we have, when we have more than one possibility of a root cause outcome on the 5 whys, then how can we be so sure about asking whys and getting down to the root cause on this?
See, if you
there
have
is no
more
statistical method, there is no structured method here. It's only presumption and keep on going on that, even though the problem is simple in appearance.
This is similar to brainstorming. You need to have only people who are having relevant knowledge, expertise, experience, okay, and even consultants. You should never ever call anybody who is having in-depth knowledge in the process. Okay, people who are facing the pain, people who are facing the loss, they only will be committed to identify the root cause. If you call somebody for time pass, definitely they will spend the time in a funny manner, and they will keep on giving suggestions that is quite comedy in nature, comical in nature, and time passing. So you should not entertain that kind of people or personality in this forum. So ensure that people who are committed to identify the root cause, people who are facing the problem, people who are losing money, people who are facing the customer, they only will know the pain. So you should have that kind of people alone. So they will be able to understand the issues. They will be doing a committed discussion. They will be doing a proper YV analysis instead of shifting the focus to something which is not relevant. So if your YV analysis identifies more multivariant causes, go for fishbone diagram. It is a next level issue. Okay, you cannot resolve using YV analysis. You have to go for a fishbone analysis. Okay, that is the only option available here. Okay, so if you feel that your YV analysis is not going to end up with the root cause or with the proper cause, okay, go for a fishbone diagram by listing out all the causes and identifying listing out all the causes that comes out of the YV analysis into a graphical representation tool called the fishbone diagram. Okay, that is how you can come out of this. You cannot come out of this YV analysis if you have multivariant causes. Okay, the fishbone diagram alone can help you to do it in a systematic way. Okay, so let us move to the fishbone diagram where you will be able to address this kind of causes. wishbone diagram. So this wishbone diagram is also called as the Ishikawa diagram or cause and effect diagram. It's a powerful root cause analysis tool. It will help you to systematically identify and organize the multiple causes of a problem. Okay, not like tools like 5 Whys. See, 5 Whys is just a linear tool. It can work in single dimension alone. But this wishbone diagram allows analysis of problems with many contributing factors. See, in 5 way analysis or YV analysis, okay, if you have more contributing causes, it will create a complexity. As said by Barney sir, it will create a lot of causes. It will be difficult to do a 5 way analysis. So to handle that, go for a fishbone diagram or cause and effect diagram. Okay, so this fishbone diagram allows us complex analysis of complex problems with many factors, with many causes. So the structure looks like a fish skeleton. That is why we represent with the name called fishbone diagram. Okay. So the visual format helps our top management as well as the team to identify the possible causes without missing any critical causes. So our ultimate objective is to identify all possible causes and put them in the diagrammatic representation, called this wishbone diagram. Okay. So see, what is the important thing which you must understand is, see, most of the top management guys may not be technically skilled, may not be technically knowledgeable. So if you put them in a essay or table or some kind of paragraph format, they won't be able to read and understand. But if you put all these causes into a fishbone diagram and put them in a A3 or A4, and if you place them in the table, they'll be able to understand easily. So if any approval you are seeking from them for project or for executing some new tools or techniques, you will be getting it easily. So a graphical representation which will help a visual representation of the causes, which will help anybody to understand it clearly, easily in a most grammatical manner. Okay, so the fishbone diagram uses, generally we have 6 categories: man, machine, method, materials, measurement, and environment. It is general. If you want, you can add more. If you want, you can eliminate. If you want, you can cut down. Okay, so each category is a major heading under which sub causes are going to be listed. Okay, so this helps you to ensure a comprehensive exploration of the problem. That is, a overall complete comprehensive uh, exploration, a search of the problem has been condensed into a this fishbone format, into a graphical format. So all the causes which may be responsible for the particular problem is listed out in one way or another. Okay. So here this fishbone diagram helps you to identify all potential causes. Okay, organize the results. See, for example, in brainstorming, as I said earlier, you are getting out nearly 100, 150 causes. How you are going to organize and keep it more understanding? I said about one tool, right? Affinity diagram. Affinity diagram puts in the format of a group, but here you are putting that in the form of a more diagrammatic visual representation, so that our understanding about that particular problem and the connectivity with the problem of the causes increases. Okay, so definitely we are going to use the result of the brainstorming and the YV analysis in the fishbone diagram. Okay, let us see some of the examples. Guys, you have this mini tab with you, right? Guys, you have the mini tab with you?
No.
Tab.
No.
So yesterday, I believe some of you worked in the mini tab, right? So anyway, we will do a mini tab. We will generate a fishbone diagram using a mini tab, guys. So it will be quite interesting. So for that, I will share the screen. I have to share the screen. Guys, are able to see the mini tab? This is the mini tab worksheet. Yes. Okay. So now, so actually I had some examples worked out. See, for example, I have the list of causes and the tools, causes and the main headings. For example, in a software company, okay, there was a problem with the execution of there was a problem in the delivery time. So what may be the reason? So using brainstorming, what may be the root cause? Using brainstorming and why analysis, we have arrived at a lot of causes. And regarding the manpower, okay, developer skill and the testers oversight of certain problems and managers poor planning and analyst misinterpretation, support staff delay. This may be the reason on the manpower side. When it comes to machineries, server downtime, building systems, okay, tools not configured properly, database working in a delayed manner, network unstable. Then when it comes to material, okay, the requirements are not clear. Okay, the requirements are not clear. Okay, then documentation and similar causes are identified. When it comes to method, the standards followed for coding, testing practices, agile process implemented, then similar things. When it comes to measure, okay, that is measurement, metrics collected regarding the project, defects collected, performance metrics of the project leading to wrong calculations, user customer feedback ignorant, and data logs not properly analyzed. When it comes to environment, heavy workload, people working from home, so communication gap, time zones, okay, noise and distractions in home and other workplaces, infrastructure and cloud issues. So very simple. You just click on statistics, control charts, quality tools, cause and effect diagram. Okay, here you can see what are the things. Personal is equal to manpower. Machine. Then materials, I put materials. Then methods, that is methodology. Then measurement is measure. Then environment is environment. So these are the labels which are already present in the meter. And this is what is followed by my team. Now, what is the effect? Project delayed. Click on OK. I'm able to get a cause and effect diagram easily, just like that. So if you put this kind of structural format, that is the graphical format, in the table of your meeting, at top management meeting, they'll be able to understand and accept your claim correctly without any objections. Let us get some mechanical, for example, CNC. Okay, let us put some mechanical examples for a cause and effect diagram. So here, okay, what is the issue actually? The effect is the breaking of the tools. The effect is the breaking of the tools. The CNC tool seems to break frequently, okay, before its lifetime. So we conduct brainstorming to find out what are the causes. And after so many causes were listed out, we are categorizing them. First in manpower, operator's skill, technician's fatigue, helper's negligence, inspector's oversight, that is inspector failing to identify the fault. Then operator's improper setup, okay, of the machine tools. Then when it comes to machine, CNC machines are not aligned. The machine tool is not aligned properly. Fixtures are loose, vibrating. Spindles are running out so that the tool wear happens immediately. Coolant not flowing correctly. Okay, machine tools wear more because of other factors. Okay, then when it comes to materials, hardness of the raw material is high. Okay, there is no verification. Components may be defective. Tool may be defective. Okay, lubricants, contamination. See, these are the possible causes which may be responsible. So anything which you found that is connected, which may be connected, has to be listed out here. Fastness, if they are not of correct specification, then they may loosen up easily, and because of that, it may happen. Then methods, cutting parameters, poor feed rate or speed is set. Tool selection, improper tool selection. Lubricants, improper method of selecting lubricant. So standard operating procedures not followed. Sequence not followed. When it comes to measurement, vernier caliper errors possible. Gauges improper usage. Inspection not done. Okay, testing is avoided. Human error. Instruments not calibrated. Environment, high temperature, dust, humidity, poor lighting, ventilation. See, for example, you can further, okay, find the sub causes also if required. Causes. Okay, supervisors. See, under manpower, there is a column called supervisors. Okay, under the manpower, there is a column called, okay, inspectors or supervisors. So the supervisors, if they are overlooking, okay, and because of poor planning, see, you can find the sub causes. Sub causes is the one which is found below the causes. Okay, the supervisor may be doing poor planning. He may not be monitoring properly. He may be making poor decisions. He may not be giving correct communications, instructions, and he may be allocating improper work so that the work is not balanced. Then when it comes to machinery, the robot which is rotating the tools may be having a problem. So under the robots, there is under the machine, okay, there may be a sub cause like programming of the particular machining not done properly, sensors, calibration error, path, maintenance. Then under the instruments, that is measuring instruments, micrometer may be veered off, sensors may be drifting, that is not in correct positions. The accuracy of the measuring, that is coordinate measuring methods, accuracy may be wrong. The torque wrench may be incorrectly set, so it may be either too tight or too loose. The bolts which are tightened using a torque wrench maybe too tight or too loose. Software tools, okay, maybe giving you wrong feedback or input to the robot which is doing it. So how to develop a cause and effect diagram? Very simple. Statistics, quality tools, cause and effect diagram. So already we have this men, machine, material method, right? We will tell it men, machine, third one is material, C3, fourth one is method, fifth one is measure, sixth one is environment. Okay, then under man, we have this inspectors. Inspectors, you can click supervisors, click OK. Then similarly, under robot means machines. Under machines, you have fixtures, CNC machines. You fix the robot. Okay. Then under measurements, instruments. Okay, click OK. So here now you are going to see root RCA with the subcauses also. Here you can see, guys. See, under that specific cause, there is subcauses. The subcauses also mentioned like this. Okay, so sometimes you may be using Y-way analysis and finding a lot of separate causes below the subcauses. See, for example, let me give you a very simple example. In an automobile company, there was a discussion, brainstorming was going on. The production was affected. The production flow was affected. Instead of 1,000 cars, they have manufactured only 900 on the previous week. So a brainstorming was going on. So in between that, an engineer was saying, sir, the welding robot was not working properly. Thank you. So you may have a Y-way analysis. Why the welding robot was not working properly? Because there was the welding robot arm was not moving freely. Why it was not moving freely? Because the bearing was overheated. Why the bearing was overheated? Because it was not lubricated properly. Why it was not lubricated properly? Because the lubricant pump was not supplying sufficient oil. Why the lubricant pump was not working properly? Because there was dust in the particular filter tank. There was dust in the lubricant tank, so which clogged the particular foot valve of the lubricant pump. Okay, obviously the reason why the pump was clogged with dust, because there was no strainer in the foot valve. There was no strainer in the inlet of the pump. If there was a strainer, it might have filtered the dust particles, the metal particles. So obviously, because a robot was affected the production, because there was no strainer in the pump. Okay. So like this, you are able to find the sub-causes. You are able to find the sub-causes under the cause. Okay, so all the sub-causes can be written like this. Okay, so overall, the cause and effect diagram helps you to find out the possible cause and the sub-cause. Okay, so all the causes which you identified using brainstorming and YY analysis can be listed out here in the form of a graphical image. Okay, this is how you can generate a cause and effect diagram. You can type it in the Excel sheet also, or you can draw it manually using in a A3 sheet or A4 sheet, just using a scale and pencil. You can do it anyway, manually using scale, pencil, Excel sheet, or using a Minitab. Any questions here, gentlemen? Any questions? See, still you can go for a paint. See, for example, let me give you a example from a paint shop. Okay, how to generate a cause and effect diagram for a paint shop. See, I have pasted the causes. This is man, right? Okay, these are the main causes. These are the main causes.
Yeah.
And machine, material, method, measure, environment. Used for column 1.
Doctor, that data is not copied, pasted correctly. They're not in the column 1.
Sorry? Oh, sorry. It's clear. Okay. So here under man, you have a lot of reasons for the
hello.
painting. Yeah. Yes, Vijay.
Sir, I have a question.
Yeah.
I have a question, sir.
Yes, please go ahead. Yes, Vijay Kumar. Are you able to hear me? Yes, Vijay Kumar. Are you able to hear me? Yes, guys, are you able to hear me?
Yes, sir, we can.
Yeah. Sir, usually the fishbone diagram depends on 4M, like man, machine, methodology. Man, machine, method, methodology. You have listed.
Yeah. Please
Yeah. I can hear you, sir.
Yeah, go ahead. Go ahead with the question.
Yes, sir.
Yes, it is listed in man, machine, material, method, measure, and environment or mother nature. This is the standard set of categories. Yes, Vijay Kumar. This is a standard set of categories. This is a standard set of categories. Okay. So if you want, you can add more. If you want, you can eliminate. Vijay Kumar, do you get it? If you want, you
Sir,
can add.
usually the fishbone diagram is dependent on the 4.
Yes, man, machine, material, method. That is what you are saying, huh? Vijay Kumar, we are getting discontinued voice. Siva, என்ன join பண்றீங்களா? சரி, வந்து ஒரு கன்க்ளூஷன் கொடுத்து ஒரு 2 minutes கொடுத்து க்ளோஸ் பண்ணிருங்க. Okay. So finally, actually, this is the list which we arrived from causes. Okay. So what you can do is very simple. If you don't want, you can remove any of this. If you feel this heading is irrelevant, if you feel this group is irrelevant, you can close it. No need to have it. You should have only causes which is relevant, which is connected with a particular cause, which is connected with a particular effect or the problem. As per Vijay Kumar's concern, he feels that measure and environment is not a part of his regular root cause analysis or this fishbone diagram. So if it is not connected with the problem of his process or the organization, no wrong, you can eliminate that. There is no wrong in that. If you feel this is not irrelevant, you can remove it. No need to list it out. Just simple. Using this tab, you can do it easily. Okay. So first heading is men, second is machine, third is material, fourth is method. And it see here the causes must be in the same order like which you have pasted. Fifth one is measure, sixth one is environment. Okay. Then if you have any sub causes, for example, under a man, if you have any sub causes, you can add it. But here we don't have any sub causes. Okay, if you have any sub causes, you can add it. But here we don't have any sub causes, so it is not responsive. Okay, here it is because of painting.
Sir,
Poor
once again, can
quality
you
of
to
painting.
this option, sir, from where you are selecting this?
So actually, I am not selecting. It is already available. See, here you can see in the table, you have see the 6 main groupings, right? Men, machine, material, method, measure, environment. When I click on this.
No, no, sir. To bring this toolbox, from where selection has to be made?
This one.
This
You
one.
have to come from stat. Stat, closer. Go to stat, go to quality tools, go to cause and effect. But prior to coming here, you must have brainstormed and you must have captured the data, and then you must have categorized the data in 6 columns. C1, C2, C3, C4, C5, C6. C1 is about men. So you can remove the causes here, sir. You remove first everything. Remove everything. You can delete. Men, you delete. Now, similarly, you delete everything. This is how it will appear. Now, under personal, you place your cursor on the personal. So, the causes, the previous column. Place here, yes. Now, from the left, you can actually pick up column 1. You select, click column 1, select. Oh, already has come. Or because you double clicked, right? Similarly, for the second one, you double click C2. And the third one, you double click C3. The fourth one, you double click C4. Fifth one, you double click C5. Sixth one, you double click C6. And the Y variable is the head of the fish is defined as project delay. Why project delay?
Poor painting.
Okay, poor painting. Poor painting. And now you can click OK. Now Minitab will generate a fishbone diagram for you, which you can copy and include it in your project document, right? Please note here all the variables which can affect the paint quality must be included in the fishbone diagram. Otherwise, you are hiding some causes to the project team or the project leader. So you must put all necessary efforts to visualize all possible reasons or all possible causes that can affect the paint quality. Whatever the factor that have some influence, that must be listed. Whether that is the exact root cause or not, that's not our point of worry right now. If it can influence, it must appear in fishbone diagram. So the requirement is fishbone diagram can be a fully loaded diagram. Even if there are 100 causes, you can literally show all 100 because we are not going to take action on each of these causes. We will further drill down, find out the most likely causes. Then once the most likely causes are let's say in a manageable number, then we validate them one by one. Only if the most likely cause gets validated, then the action will be taken. So that's how you make use of the tools for root cause identification. And the steps will be like this. Identify the possible cause, then separate the most likely cause, then validate the most likely cause for its significance. If the validation also confirms, then the most likely cause can be declared as the root cause. So how to validate? Yes, I will be explaining you tomorrow. So I hope you understood, the tools today, by discussing with Dr. Ravi Kumar. So are there any question to Dr. Ravi or me so that we can conclude today's session?
Sorry to repeat the same question, sir. You said stats and after that it is charts. Am I right?
No, in the Minitab you are asking, right?
Yes.
You should go to stat, come to quality tools, choose the cause and effect.
Okay.
Then if you give okay, some window will appear. In that, even before doing all these things, you must have 6 columns of data in Minitab, isn't it? You must have typed. How will you get this data? Through brainstorming.
Right.
And then category wise, man, machine, material, method, mother nature and things like that. And then you have to feed, in the corresponding column. And Y variable also don't forget to include, so that the head of the fish will carry the Y and the bones will talk about the X. Here the outcome expected is as many X as possible. What is the outcome expected? As many X as possible, because we are finding the possible causes only here. But how the possible causes, how we separate the root causes from the possible, I will explain you tomorrow. Okay?
Yes.
Shall I get a response?
Yes.
All right. So, shall we close today then? Ravi Kumar sir, thank you.
Yes, sir. We can do.
Thank you, Dr. Ravi.